Our second problem is a continuation of our first problem. It's basically asking us to do the same thing, except this time account for friction. So I've already drawn out the picture of this problem, and all we're going to be doing is we're going to be factoring this friction. So I'm still going to go through all the steps, but this should be relatively easy because we already know what it looks like to break up this vector into x and y components. So let's do a free body diagram so that we can figure out all the forces we're working with. So I'm just doing a small one right here. I've got a downward force of gravity. I have a reactionary force of Fn. I have a force pulling this way, which is going to be the x component, Fx. I have a frictional component, F of friction. And then I have another component on top that's going to be the Fy. So, the way we're going to look at this is we're going to figure out what is our force normal, so that we can use that to figure out our force of friction. Because this is pulling upwards as well as to the right, it's going to be pulling off the ground a little bit. So that's going to reduce our total force of friction by reducing the force normal. Because if it's not pushing as hard into the ground, even though it still has the same force downwards, some of that is being relieved, and the ground is not going to push as hard back up against it, which is going to cause a lower friction. So we'll go ahead and label out those forces. We have 5 of them. So F, in fact, let's actually do the vector as a 6th one. So FV for vector is going to be 400 newtons. F in Y, F in X, F G for gravity, force normal, and force friction. Okay. And then we have our mass, we have our acceleration due to gravity, we have our mu, K. Okay, mass is 70 kilograms. Oh, and let's go ahead and account for theta as well. Let's put that on our variable list. Our degrees, 30 degrees. Our acceleration due to gravity is negative 9.8. Our coefficient of friction is 0.35. And let's see, do we know anything else? Do we know anything else about this? No, okay, that's all the information that we're given to start with. So we can use that to first find the force of gravity, the force in y, and the force in x. And then we're going to use the force of gravity and force in y to determine force normal. Then, once we find force normal, we're going to determine the force of friction. And that's going to be in opposition to the force in x. So we'll go ahead and compute those values. Starting with the force of gravity, because that's the easiest one to do. So force of gravity is going to be mass times the acceleration due to gravity. So that's going to be 70 times a negative 9.8. I can't use my calculator and talk at the same time, apparently. So that's going to give me a negative 686 newtons. Excellent. Next, let's find our force in y and our force in x. Now remember, because we're dealing with a vector pulling it this way, we're going to have our cosine is going to represent our x, and our sine is going to represent our y. Because we're working with this angle, and remember, so, ka, toa. Sine is opposite over hypotenuse, and that's going to be the opposite side, which is going to be our force in y. So, sine theta times that 400 newtons is going to equal the force in y. Likewise, my adjacent line is my force in x. So, that 400 newtons times the cosine of theta is going to equal my force in x. Those are actually pretty easy to punch in the calculator. It just requires us to think about it first. It's not something that's just automatic quite yet, but you'll get there with time. So 400 times the sine of 30. That's going to give us 200. So my force in y is 200 newtons. My force in x is 400 times the cosine of 30, which is going to be 346.1 newtons, equals my force in x. Okay, so let's go ahead and put those into our variable list. 346.1 newtons and 200 newtons. Excellent. Now, force normal, if you notice, you've got force normal and force y, and then force of gravity. These are reactionary forces. Whatever happens, unless this is accelerating back and forth, which would only be the case if the force of y was greater than the force of gravity, which it is not, then what's going to happen is we're going to set up an inequality. Our total is going to be 0, so I know that force of gravity is going to be equal to the force normal plus force in y. Okay? Great. So, force of gravity is a negative 686 equal to force normal plus force in y, which is 200. Okay. Now the other thing to remember is because these are reactionary forces, they're actually equal to the negative force of gravity. Okay? So these are going to be positive, this is going to be negative, because our frame of reference has down as the negative. Okay? Great. So, in that case, this 686, we're going to make it positive. And then we're going to subtract 200 from both sides. And that'll give me a 486 for a force normal. Excellent. 486 newtons. And then, force of friction, remember, is the force normal multiplied by the coefficient of friction. And it's going to end up being a negative number. So it's going to be the negative force normal times the mu k. Man, I got to get better at drawing those mu's. I'm not used to it yet. Maybe I just do it slower. Okay. Force normal times mu k. So, negative force normal is going to be negative 486 times mu k, which is 0.35. Okay, let's calculate that. And that's going to give me a negative 170.1 newtons. So, what I'm going to have then is a net force that is Fx minus Ff. Okay? So, let's go ahead and create a space for ourselves here. In my safe space. Force net equals Fx, not F of x, but Fx, plus, it's always the sum of the forces, force of friction. So remember, this F net is always going to be the sum of forces. It's always going to be plus. So if you're supposed to have a 0 for an F net or something, or you know something's supposed to equal a certain number or some kind of equilibrium, and you add them together and you get a wonky number, you should go back and check the signs on your forces. Make sure that everything going to the left and down is negative and everything going to the right and up is positive. Your forces should balance a little better then. So Fx, we know, is 346.1. Plus, force of friction, we know, is negative 170.1. So that's going to be our F net. So, subtracting those is going to give us 176 for an F net. So 176 newtons. Now remember, F net is the sum of the forces in the direction of the movement. It is also, a little safe space for ourselves, F net is also equal to ma. So I'm being asked to find the acceleration in this problem. So to find the acceleration, I need to take this F net divided by that mass, divided by 70 kilograms. and that will give me the acceleration that I'm looking for. So 176 divided by 70 gets me 2.5 meters per second squared. Okay, so that's the answer, is 2.5 meters per second squared, our acceleration, 2.5 meters per second squared. That's what we're looking for. Thanks, guys.